All right, what's up, mathletes? Here we go. Jumping into 5.1, operations with complex numbers, or also known as imaginary numbers. And we're going to start with a little bit of radical review today. So when we're simplifying a radical, all it is breaking it into a factor tree. So remember when we had this like factor tree of 20 and we went 2 and 10 and 10 went to 2 and 5 when we got all of its prime factorizations. So we're going to do the same thing, but we need to pull perfect squares. So for 20, a perfect square would be 4, and then 4 times 5 gets me to 20. All right, so we're going to talk about how to simplify radicals today. So definitely, you guys need to have these memorized. These are all the way up to 12, your perfect squares, and you need to know what they equal, right? Square root of 81 is 9. Square root of 36 is 6. So a perfect square happens when you take that number, 6 times itself equals 36. So that means we can break down the square root of 36 into just 6. All right, so you guys definitely need to have those memorized. So let's look at a couple here. So I need the square root of 40 to break down into two square roots. One of them has to be a perfect square. So the largest perfect square nearest to 40 is 36. Well, in my calculator, if I do 40 divided by 36, I get a decimal. So we're going to move down to 25. 40 divided by 25. That's 1.6. It's a decimal again. So I'm going to move down again. Guys, I'm just looking at that list I gave you, and I'm going to do 40 divided by 16, still a decimal. 40 divided by 9, still a decimal. And at 4, it divides out to 10. So we can separate 40 into the square root of 4 and the square root of 10. Now, getting the largest number that you can will allow us to only simplify one time. At this point, I can say, all right, well, what is the square root of 4? Because it's breaking down into this. Because if I multiply backwards, square root of 4 times the square root of 10 is the square root of 40. So we're just kind of breaking it down. Well, what is the square root of 4? It's 2, so we get it out of the square root. So that's why we want our perfect squares. We want to get that number out of the square root, and then we just tag it up with square root of 10, and we know that the square root of 10 cannot be divisible by another perfect square. So we stop there. So here I've got 2 times the square root of 68. So I can just bring that 2 down, but I want to find what's going to divide into 68. So I'm going to do 68 divided by 64, and that doesn't work. And then I'm going to do 68 divided by 49. That doesn't work. 68 divided by 36 doesn't work. 68 divided by 25 doesn't work. All right, 68 divided by, I'm just going to move on down. And again, our biggest is 4. Okay, so 2. And I'm going to break down the square root of 68 into 4 times 17. So 68 divided by 4 is 17, so we can break that down. So that 2 is going to stay with us. Then the square root of 4 is 2 outside of the square root. All of this is multiplication. So I'm going to multiply that and then times the square root of 17. So all we did was bring that down, bring down the square root of 4, and bring down that square root of 17 that can't be reduced. And now I've got 2 times 2 is 4 times the square root of 17 for this problem. So I know you guys have done this in the past. Here's just a little review on it. All right, square root of negative 200. So this is where we're going to start talking about imaginaries a little bit. Anytime you have a negative number, we can bring that out, and it is automatically an I for imaginary. All right, so we're going to break some things down. I is actually the square root of negative 1, which is why we can use that as part of our factors. And I need 200 to break down. So the biggest square root that's divisible into 200 is 100 times 2. So we've got 100 times 2 times negative 1 gets us to negative 200. Square root of 100 is 10 outside of the square roots. Square root of negative 1 will always come in as an I, and that goes after my number. And then that square root of 2 can't simplify, so that just comes down. So as you can see, we're just breaking it down into factors, specifically perfect squares. All right, this one's -2, so I already know that at the end, I'm going to have an I. So let's just look at square root of 20 and square root of 36. So the square root of 20 breaks down into the square root of 4 times the square root of 5. So 4 times 5, we're looking for perfect squares, that's this guy, over the square root of 36. Well, we know the square root of 36, right? So we can really keep that here. That is a perfect square. So let's simplify. Square root of 4 is 2. Square root of 5 comes with us because it can't reduce. And the square root of 36 is 6. And we still have that I we took out earlier. And now we can do a little bit of reduction here. Just looking at my coefficients out front, I can divide both of them by 2. So I'm going to go ahead and divide by 2 on top and bottom. That's going to get me 1i square root of 5. I am not touching my square root ever when I simplify, divided by 3. And we don't have to put the 1 here. So I kind of works like a variable. If it's 1 out front, you don't need to put it. So that's how we would simplify that one. So let's jump into imaginaries a little bit. So an imaginary number is the square root of -1. That's what we talked about. It is I. So if I squared that to see what I squared would be, anytime I have a square root and I do the opposite, and the opposite of square root is square, all that's going to do is cancel the 2 out, leaving us with -1. So I squared is equal to -1. We're going to use that a ton, all right? So remember, I squared will always get you -1. Here's our little key over here. I is obviously I. I squared is -1, which we just found out. Well, if I take I squared and multiply by another I, so I take -1 and multiply by another I, that's how I get that I to the 3rd power is -I. And I to the 4th is 1. And that's going to be a big hitter for us as well. We're going to use that a ton. So I really want you guys to make sure you have these two down, right? So if I have I squared times I squared, that's just -1 times -1. And so I to the 4th equals +1. That's how we get that guy. So those are our 2 huge things we're going to use in imaginary numbers. So we really got to make sure that that is memorized. So I'm going to use multiples of 4 when I'm simplifying my i's, because anytime I have a multiple of 4, I know it's 1. And in math, 1 is awesome because 1 times anything doesn't change it. So complex numbers is the same thing as imaginary. And it just means, hey, if there's an I in there, that's an imaginary number. So you might see this set up some number times I plus a real number without the I. All right, so let's talk about reducing these down. So when I said I need to find multiples of 4, okay, that's because they all get us to 1. So if I look at 13, I want to say I to the 4th power to another power. So I want to say, all right, how many times does 4 go into 13? 4 times 2 is 8. We can go higher. We can do 4 times 3, which is 12, right? This is I to the 12th right here. And then we have 1 left over because we're actually talking about 13. So there's my 13th. Well, if I to the 4th is 1, that means we're doing 1 to the 3rd power times I. Well, what's 1 to the 3rd power? 1. So really, 1 times I is just simply I. So you want to find 4th powers, how many times it goes in, and you can just get rid of it. Okay? So we're really just kind of adding in So on this one, I'm going to say I to the fourth power. So I'm always using that fourth power, and that's special because it's equal to 1. I to the fourth power, how many times is 4 going to 20? This one does go in evenly. 4 times 5 is 20. And we don't have any remaining. So again, that just means I'm doing 1 to the 5th power, which is 1. So this problem would reduce to equal 1. All right, I to the 34th. Make sure you guys are pausing these and giving it a shot. So I want to go I to the 4th, and I want to know how many times 4 is going to go into 34. If you don't know, do 34 divided by 4 and just take the whole number of it. So it's 8.5, so we're going to say it goes in 8, and we have leftover. So 4 times 8 is 32, so I need 2 more, so an I squared left. And I to the 4th is 1. 1 to the 8th power is still 1, and it's not going to do anything. So that's why we use the 4th power, because we can reduce it down. And now we just have to reduce I to the 2nd. So you should be able to reduce it down to one of these 4 options. That's why these are super important. Well, I just look over here and go I to the 2nd. That's -1. All right, I to the 99th. So I've got 4 to the power of, I'm going to do 99 divided by 4. That gets me 24.75. So I'm going to go to the 24th power. And I'll say, all right, well, what's 4 times 24 is 96. So that means we actually have 3 remaining to get to 99. So I'm going to have I to the 3rd left over. This guy can go. And then I just look over here and say, well, I to the 3rd is -I. And here's my reduced. So this box over here is super, super important to have that in your notes somewhere that you can get to quickly. Or memorize them, even better. All right, when I'm adding and subtracting imaginary numbers, it is simply doing like terms. So I put my i's together and I put my constants together. So I'm going to do -1 plus 6, and that is 5. And then I'm going to do 2i plus -10. So that's 2 plus a -10, which is just 2 minus 10. So that's -8i. All we're doing is combining like terms. You can have this or -8i plus 5. Both are the same, just in different orders. All right, again, we're going to combine our like terms. I'll put the i's first this time. So 2i minus 8i. So 2 minus 8 is -6, keeping the label of I. And then we're going to go -5 minus 2. So -5 minus 2 is -7. So this, or if you switch it to -7 minus 6i, both are appropriate and fine. So just combining like terms. All right, here we go. We're going to go 5 plus -2 minus -3. So I'm going to write that out for you guys. 5i plus a negative, so minus 2i, minus a negative, so plus 3i. That's going to get us 6i. And then we're going to do our constants. 3 plus 5 minus 10. So -2. All right, guys, hope that helped for today. Just jumping into imaginary numbers. Please make sure you're asking us questions when you have them.